All right, Pre-Cal 11, welcome to section 4.2. So after that rather lengthy 4.1 video about the basics of a parabola, we're actually going to look at now how do we get the equation of a parabola from a graph, how do we work with a whole bunch of different pieces within that, how do we get a vertex, so on and so forth. So hopefully this won't take as long, and you'll see this time there's blank examples that I'm going to work through. So here we go. Equation of a parabola. Probably the easiest way to start is, well, what is the vertex of my parabola, right? What's that minimum or maximum point? I'd like to know that. And then the value that determines the shape, you're going to see that what we do is we will call that the letter A in our standard form equation. So let's just look at this first example. We have a drawing here of a graph, right? And the first thing we want to identify is, well, what's the vertex? And it's staring us in the face. It's right here. And what are the coordinates of that? So we can say, okay, well, we know that the vertex is at -2, 5. And we know that from our standard form equation, my vertex equation is an A value. So remember that. That stretch piece or the reflection piece, the over 1 up 1 is a basic. So then over 1 up 2, the A value would be a 2. But in this case, we don't know what it is. All we know is we have this graph, and we know that my vertex is at -2, which means x is -2, so it's +2 squared, and my vertical shift is +5. So that's the equation that you get just from the vertex. All we've done is plug the vertex into this equation. Remember, x minus c squared plus, remember what letter it was, d, but that was our standard form equation. So now that we have this, we need to figure out, well, what's a? Now, there's a couple ways you can figure this one out. You can do your sort of cheeky thing that I demonstrated last time. So like normally we would go over 1 from the vertex, and in this case we're going down, so we already know a is negative. Right? So normally we'd go over 1, down 1. We haven't done that. We've gone over 1 and down, well, less than that. Can't really pinpoint, can't say a half, can't say a third because we're not sure. We've gone over 2. And normally we would go, if it's negative, down 4. We've only gone down 2. So what's the difference between going down 2 and down 4? Well, a half. So for me right away, that jumps out that my A is equal to a half. But let's work it out mathematically. And to do that, you plug in any other point you have on the graph, and here we're given a few points. We're given 0, 3, we're given -4, 3, we're given -6, -3, and 2, -3. You can use any of those, and what you do is you plug them in for the x and the y in the equation. I'm going to use this one just because I like using equations with 0 in them. So in this case, y is 3. A is what I'm trying to find. X is 0 plus 5. And let's solve this through. So 3. A, we have 2 squared, so times 4 plus 5. So now we have 3 equals 4a plus 5. Subtract 5 from both sides. -2 equals 4a. Divide both sides by 4. -2 over 4 equals a, or -1/2. So you can see we worked it out mathematically, but we also worked it out intuitively here. And the only thing left to do now is to complete your equation. So what is the equation of this parabola? Well, we have all the details we need. X and y just stays xy, right? The equation of this parabola is y equals, now we know our a term, -1/2 times x plus 2 squared plus 5. So there you have your vertex and your a value, and you're all done. So really identify your vertex, calculate your a value, and you're finished, because you don't need any more info. So here's another one, and I'm going to calculate it mathematically, and then we'll do the over 1 and up however many to look at a different way. So vertex is right here, right? We are at 1 and -4. So vertex is 1, -4. That means in our equation, when you have x minus c, right? It's going to be x minus 1. Because if you put a 1 in for x, that whole thing equals 0. And then instead of being plus d, it's going to be minus, because it's negative, minus 4. So now, what's a? And again, use any other point on the graph. You can't use the vertex. It won't work. Because if you plug the vertex in, you're just going to get your the y equals your d value, which you would expect. So you need to use a point other than the vertex. So we have this one here at 2, 4, and we have this one here at negative 2. Sorry, that's not 2, 4. What a rookie. It's 4, 2, and negative 2, 2. Pick either one. I'm going to go with this one. So my y value is 2. My a value, I don't know. My x value is 4. And now I'm going to solve. So 2 equals a times 3 squared minus 4. 2 equals 9a minus 4. Now you have add 4 to both sides. So 6 equals 9a. Divide both sides by 9. 6 over 9 equals a, which is a equals 1 over, sorry, not 1 over. Divide them both by 3. A equals 2 over 3. So that's a more challenging one to look at with respect to your over how many and up, but here's how to do it. If I go from my vertex to the only other point that I have pinpointed, I've gone over 1, 2, 3. In your basic parabola, if you go over 3, you go up 9, right? In this case, we went over 3 and we went up 1, 2, 3, 4, 5, 6. So what we're saying is 9 times your a value should give you your new output. So it's only going to give us 6. And if you look at that, what do you get? 6 over 9, which is what we calculated over here. So it's a pretty handy way of doing things to calculate a when you get better at it. If you're still confused, we can talk about it in class. So now what's the equation? Y equals 2 over 3. It's positive because we open up. X minus 1 squared minus 4. We are done. So we're going to move on now to the next page. Now, the next page we start to look at what's called completing the square. Now, what you'll notice in your notes, I'm going to do this whole thing, but I'm actually going to split this page in half. And I'm going to do it with letters and then with a numerical example. And then we're going to do a couple more numerical examples after. With letters can be a little confusing. Your notes are also going to be done a little bit differently than I do them here. So bear with me, try your best to follow. It'll be a little bit better when we do the numbers. So we're going from this form to this form. So if you have y equals ax squared plus bx plus c. Now, we're trying to get it, so we're doing what's called completing the square. So we're trying to get a perfect square with my x's. So first thing you have to do is essentially boot the c out. Like, just don't worry about the c. Okay, it's your friend, it's not your family. It's just hanging out. Now, from the two x terms, what you're going to do is you have to factor out an a. Now, obviously, if the a is 1, it's easy. And I'll show you that in a few minutes. But if we factor an a out of just the x terms, you're left with x squared plus b over a times x. Now, because if you multiply that a in, the a's will cancel. And then this plus c is just hanging out over here. Now, the next step, you have to divide this term. Now, this is why it gets complicated in letters, because it's not numbers. When it's numbers, it's easier. You're dividing by 2, or you are multiplying by a half. After you do that, you have to add and subtract that value squared. So bear with me here. Got the a factored out, got x squared, got my plus b over a times x. Now I'm going to add, so I'm going to divide it by 2. So b over 2a squared. I'm going to add it, and I'm going to subtract it. Now what I'm going to have to do here is just make a little bit more space. I'll come back to this after. okay? Because we still have that. So this is all in brackets, b multiplied by a, and then you have your plus c. Okay, now we need to remove this part from inside the brackets. Now what you have to do is when it comes out of the brackets, remember it is being multiplied by a. So when it comes out of the brackets, it has to still be multiplied by a. So x squared plus b over a x. Now we're going to have plus b over 2a all squared. But then this negative b over 2a is coming out, and we're multiplying it by a. Well, what happens is we get this. Negative a times b over 2a squared plus c. So I know this is a little confusing. Might have to watch this a few times. Now, this is why we're doing this. Because on the inside now, what we have is we have a perfect square, right? It's this is a square right here. This is a square right here. Think about adding b over 2a to itself. You get b over a. So this actually factors out to x plus b over 2a all squared. That's the point, because this is the x value of our vertex, right? And then here, this minus a, so you have minus a times, I'm going to multiply, or I'm basically going to do the exponent. It's a times b squared over 4a squared plus c. And so there's brackets here, which then works out completely to a times x plus b over 2a all squared minus, now this a cancels with the squared, so b squared over 4a plus c. Now that doesn't mean a lot to many people, but that is where this equation comes from, and that is what we're going to do every time we complete the square. So since, I believe on this page it goes, yeah, so this is a stretched down page. So what I'm going to do is I'm going to do a numerical example for you right now just to kind of show you how that makes sense. And I'm going to use my x value equal to, or my a value, sorry, equal to 1, just because it's a little bit easier to understand that. And then the next example we see will have a different a value. So I'm going to take this, x squared minus 5x, then let's go plus 6. I am going to complete the square. So the first thing I'm going to do is I'm going to disregard the c term. I'm going to keep it outside brackets. Now is when I would factor out the a term, but there's no a term, so I don't have to factor anything out. And you know what? I'm sorry to do this to you. I'm going to change this because I don't want an odd number, because it's going to make things more confusing than they have to be. I'm going to change these numbers. I'm going to put a 4 here, a 4 here, and I will put this is why you don't do things off the top of your head. A -5 and a -5. Okay, so just makes the numbers easier, because no a term, right? A equals 1, so nothing to factor out. Now, take your b term, divide it by 2, and then square it. So 4 divided by 2 is 2. 2 squared gives me 4 back. So I'm going to add that, and I'm going to subtract that. Reason why you do that is because this equals 0. You haven't changed your equation. And then you still have this -5 over here. Next thing to do is to take the negative portion of what you added and subtracted, and it comes out of the brackets. You multiply it by the a term, but the a term's 1, so it doesn't matter. So now you have x squared minus 4x plus 4 minus 4, because this -4 comes out, minus 5. This is now what we call a perfect square trinomial, and it just simplifies to x minus 2 squared, my a term is a 1, minus 9. You have changed this into vertex form, and your vertex is 2, -9. 9. All right, so that's completing the square. Now remember that this is in your notes. You can look at it. Don't get too boggled down with this letter version. It's just I know it doesn't look that way because of my handwriting, but it's the mathematical beauty of how things work. Now there's also a vertex formula, and you'll see on this next question, it's right here. But I am a very, very, very firm, and like, where did this formula come from? This formula came from that equation manipulation that we just did. I'm a pretty firm advocate of not trying to memorize formulas. Also, I'm an advocate of giving you a formula when it's something like the quadratic equation or a sequence and series formula. But when you can calculate completing the square, which is this good skill to have, I'm not going to give you the formula. So I don't want you to get all gung-ho on memorizing this formula. I really want you to practice completing the square. So here we go, example 3. We're going to complete this square. Okay, so here we go. First step, we disregard the c term. So y equals 2x squared minus 4x in brackets, and we leave the c term on the outside. Factor out your a term, which in this case is a 2. Now this tells you right away already that you're going to have an a term of 2. There's no way it could be negative. You would have factored it out already. So you get your a term right away, which is kind of handy. Now we do that whole, whatever your b term was, so in this case now it's negative 2x, divided by 2, you get negative 1. Square that, you get 1. So add and subtract that. Okay, now we are getting this guy out of the brackets, or girl, out of the brackets. But you have to multiply it by your a term, remember. Don't forget that, because it's being multiplied by that a term. So when it comes out, it has to be equivalent to that. So 2, now you get x squared minus 2x plus 1, but then minus 2, because negative 1 times 2, then minus 3. Now we have a perfect square trinomial. So you got negative 2 and plus 1. You're looking for two numbers multiplied a positive 1 and add a negative 2, and it's just negative 1 and negative 1. That was the goal. So x minus 1 squared. And then minus 5. Boom, we have converted into vertex form. We have a vertex of 1 comma negative 5. You can see here, plugs into the formula. You need to be in this form for your ABCs. You plug the b in, b is negative 4. You plug the a in, a is 2. Right, so, and you get the same vertex. Awesome, but complete the square. Just work on completing the square. Next example. So again, we have y equals 2x squared minus 4x minus 1. I'm going to factor the 2 out. I'm also going to boot my c term over. I'm going to take that 2, you're going to divide it by 2, you're going to square it again, we get plus 1 minus 1. Similar question, just a different result. So x squared minus 2x plus 1. When that negative 1 comes out, you're going to multiply by the 2. So this time we have plus 2 minus 1. And we end up with 2x minus 1 squared. Sorry, not plus 2, minus 2, minus 3. So your vertex is 1 comma negative 3, and you can start to graph. Okay, so let's put all of this together. Here we have a quadratic, negative 2x plus 8x minus 3. Now, if you could factor something out otherwise from each term beforehand, always do that. Simplifies your life, but we can't. So we got to graph this thing. We could use the vertex formula, or we could find the vertex. So we need the vertex, we need the axis of symmetry, we need max and min, we need domain and range. So let's do this. So f of x equals negative 2x squared plus 8x minus 3. F of x is synonymous for y. So y equals negative 2x squared plus 8x minus 3. So we're going to start with the vertex. We're going to factor out a negative 2 from just those first two terms. So plus 8 becomes minus 4, and this negative 3 is just hanging out there. We're going to take our negative 4, we're going to divide it by 2, we're going to square it, we're going to add subtract it, so plus 4 minus 4, because negative 4 divided by 2 is 2. 2 squared is 4. That's subtracted. We're now going to remove the negative portion, but multiply it by the a term. So the negative 4 is going to come out, but it has to be multiplied by that. So negative 4 times negative 2, so you get plus 8 minus 3. We now have a perfect square trinomial, so we have negative 2x minus 2 squared plus 5. Boom, vertex. 2, 5. Okay, so we know our vertex. What else do we know? We know our a value. Our a value is negative 2, which means it's going to open down. Which means we have a maximum point, right? Because our vertex is at the top because it's opening down. So let's start to model what that looks like. We can label our vertex at 2, 5. Nope. Wow, what a rookie. That's 5, 2. At 2, 5. 2, 5. Okay, now we know our a value, so you could do your over 1 down, instead of down 1, go down 2. So over 1 down 2, over 1 down 2. Normally you'd go over 2 down 4. We're going to go over 2 down 8. Over 2 down 8. If what I'm doing still confuses you, we can plug some values. Okay, I like to go over 1 for my vertex. So in our equation, we can use this equation too. Well, we can use the original equation, which was negative 2x squared plus 8x minus 3. So you plug in, if x is 2, plug in when x is 1. And solve, so negative 2 plus 8 minus 3 is 3, right? And you get your points. So you can plug and play, fill your points out. Have a look at the written example in the workbook. I show it quite nicely. But you know that your axis of symmetry goes through your vertex. So you know if you find the points on this side, they're going to have their mirror image on this side. So we have a vertex, we have an open downward, so we have a maximum. We have an axis of symmetry at x equal to 2, because it's a vertical line. And then we have a domain of all real numbers. That's fancy math words for all real numbers. And we have a range of, well, what's my highest point? 5. And y is everything less than or equal to 5. So you got all that. So you get it all from your vertex equation. So now let's look at something that requires a little bit more thought. Given that you have a quadratic function with a minimum, f1 is equal to negative 3. So what that means, f of x equals negative 3. So that means when x is 1, y equals negative 3. I don't know if you covered function notation up to this point, but that's what that's saying. When this is x, this is y. Okay, so that means you have a minimum at 1, negative 3. Well, if that's your minimum, that means that that's your vertex, right? And if that's your vertex, well, where's the axis of symmetry? It's through your x value. So axis of symmetry at x equals 1. And if it's a minimum, do you open up or down? You open up. So your range, y is greater than or equal to negative 3, its lowest value, in your domain, all real numbers. So you're starting to put things together in your head now by putting pieces of information together, and you're working through it. So a couple more examples and we're all done for this lesson. So now, example 7, determine a quadratic function with a vertex and a y-intercept. So that gives you some info. You got the vertex, so let's put this thing into vertex form. Don't know your a value, but you know vertex x equals 0, so it's x minus 2. Or sorry, vertex is 2, 1. So x minus 2 plus 1. You know that, but you don't know a. And you might be thinking, well, I don't have enough information to get a. But you do, because you're given a point on the graph, this point. What you need to put together is your y-intercept has what for an x value? 0. So you have a point. plug that point in to your equation. So when y is equal to -3, x is equal to 0. You get -3 equals a times 4 plus 1. Subtract 1 from both sides. -4 equals 4a. A equals -1. We can now write our equation. Y equals negative, and then everything else we already had. So you're taking everything you've learned and you're starting to see how these things all sort of click together and work together. So I think we got one more to go here. Find the vertex and the x-intercepts. So we got a couple things we're trying to achieve. So let's do vertex first. We have to complete the square. So to find the vertex, we have 2x plus 5x minus 3, 2x squared. Factor out the 2. So y equals, now you're going to have x squared, but now this is something we haven't seen yet, 5 over 2, because you factor it out, multiply that 2 back in, it's going to cancel that 2. So that's what it looks like when it gets factored out. You hold that position like that, and you got the c term over there. Now, when you divide 5 over 2 by 2, it's the same as multiplying by a half, so you get 5 over 4. So y equals 2 times x squared plus 5 over 2x, and then you're squaring that, so you get plus 25 over 16 minus 25 over 16, all in brackets, minus 3. So get the 25 over 16 out. And remember that you're multiplying 25 over 16 by the a term, which is 2. That's going to cancel with that, and you're going to have negative 25 over 8. So when that comes out, you're going to have y equals 2 x squared plus 5 over 2x plus 25 over 16. And then you have a negative coming out, times it by 2, which we did, so we get negative 25 over 8. So minus 25 over 8 minus 3. So perfect square trinomial means that that's a perfect square and that's a perfect square. So square root both, and you have your vertex form, and it's whatever sign is there. So it's a plus. So y equals 2x. Square root of 25 is 5. Square root of 16 is 4 squared. Now just think about that. If you took 5 over 4, right, because if you foiled this, I'm going to erase this after, but I'll just show you this right now. If you foiled this, you'd have this. X times x gives you your x squared. X times 5 over 4 gives you 5 over 4, and x times 5 over 4 gives you 5 over 4. You add those together and you get 10 over 4, which is 5 over 2, which is how we get the b term. And then multiply them together and you get back to that. That's how it all works. It's a beautiful thing. So we have all of this, and then we have minus 25 over 8 minus 3, but I don't want 3, I want something with a denominator of 8, and 24 over 8 is equal to 3, because now I have a common denominator. So I'm almost finished. X plus 5 over 4 squared, and then negative 25 minus 24 is minus 49 over 8. So here vertex, it's not the most ideal vertex, right? It doesn't look fantastic. Negative 5 over 4 and negative 49 over 8. So that's your vertex. You know your a value as well. But now we got to find our x-intercepts. X-intercepts we can find by factoring. You could use the quadratic equation, which we haven't learned yet, or we could factor this thing using the AC method. So we had 2x squared plus 5x minus 3. So AC method is multiply the a and the c term. So it becomes, right, this and this. Plus 5x minus 6. That factors to x plus 6x minus 1. But then we have to divide by our original a term. Simplify the fractions if you can. And if you can't, the denominator comes to the top. So Those are your factored forms. So what are your x-intercepts? X equals negative 3 comma 0 and 1/2 comma 0. So you get your x-intercepts, you get your vertex. I know there's a lot going on there and it's kind of tough to follow maybe on the video, so watch it a couple times. And again, if you're confused, practice, read the notes as well. It's all there for you. That's it. So I want you to practice these, and I've said this multiple times in the messages, but I want you to hear it in the video too. The workbook is the practice. Don't watch the videos and just try assignments thinking you can get it. Do the practice in the workbook. Mark the practice. Like when I say mark, I don't mean give yourself 4 out of 5. I mean check to see if the steps you're doing are the correct steps. Are you making sense of what you're doing? Do you understand? Are you growing as a learner? That's the whole point, okay? Good work today, and I will see you next video.